In this session, I'd like to talk about the slice perspective, and in particular how it can help you with cases like this, where a code base is particularly tangled and messy, and it's very hard to make sense of say, the high-level views. So I'll come back to this particular view a bit later, but first of all, I want to look at something a little bit simpler to illustrate some of the general principles. So I'm going to go into the class file area, and inside class file, in this subsystem, I see that there are 4 packages and 2 tangles, each of 2. And now that's a lot simpler to look at, but actually I'm going to simplify it a bit more. I set up some excludes beforehand, and that's going to hide 2 of those. And now I just want to focus in on this issue of a tangle, where class file is dependent on analysis and vice versa. So in my assumption here is that we would like to break this tangle, to remove the cyclic dependency. And wherever we want to achieve that, Structure 101 helps us out a bit by identifying the minimum feedback set. Now that's the minimal amount of dependencies that need to be removed in order to break the tangle. So in this case, and this is the simplest case, it's saying there is a dependency with a weight of 1 going from class file to analysis. The dependency in the other direction is much heavier. So if you really wanted to break the tangle, then the easiest way to do it would be to address this dependency from class file back to analysis. So I'm going to select that dependency now to find out exactly what's causing it, and I see that the offending item, in this case, is descriptor factory. And I guess broadly I have 2 strategies available. One is I can change the code. So for example, I can say I want to remove this dependency from descriptor factory back to method info, and maybe I'll use dependency inversion or other interfacing techniques to achieve that. The other possibility is that I move stuff around. And sometimes there's low-hanging fruit in that we can actually see that a dependency is caused because a class is in effect in the wrong package, at least from a structural perspective. And by moving that class from one package to another, we fix the problem. There's a demo on this, on what we call architecture sandboxing, on the J-FreeChart code base, which demonstrates how that would work. Now, I'm going to go down the road for a moment now of trying the moving about approach and just very briefly show why it's going to fail here. And the conclusion to be drawn from that really is that if I wanted to break this, getting rid of the dependency by changing the code is actually the correct, or probably the correct strategy. So just following the architecture sandboxing approach, I would say create a new diagram from this, select the dependency, just give it a try. Maybe I'm lucky that I can just move this in here and it goes straight away. But actually, no, if I did that, there's some more dependencies come back. That didn't work, so I'm going to undo that change. I'm going to try expanding this and see if that makes the world any clearer. And if I scroll around in here a bit, it's a bit unwieldy, but I'll eventually find descriptor factory is the class causing the up dependency. But there are lots of other things within this package, including these classes below or further down in the layering, and some of these classes higher up that are using descriptor factory. So it follows that if I move that across, then those other dependencies will follow descriptor factory, and I'll still have that tangle at the package level. I could try dragging and dropping stuff around in here for quite a while, actually, and quite possibly until I'm blue in the face, without actually achieving anything. And the reason for that is that there's a tangle lower down at the class level involving all of these. And I'm going to show that now in the slice perspective, how we can see that and maybe approach this kind of problem situation a little more methodically or systematically. So let's switch over now. And I'm going to drill down where I already did. Let me just clarify that. Pick this subset of the code. I'll pick a different one just so that we get a change in view. Pick this subset of the code, choose the outer class layer, and I'll start with the main cluster area over here. What we're seeing here is, in effect, all of the classes in this subsystem of the code base and the dependencies between them. And we've stripped out the hierarchy at this level. So we've stripped out that intervening level of the package organization. Now I can see that some of these dependencies are red. That's the minimum feedback set. And in fact, I've got them nicely shown over here. So there is a tangle in this particular graph Now, when we do this in the slice perspective and strip out the hierarchy, what we very often get is very big graphs when we select the, say, the outer class layer of the entire code base, where we've got hundreds or thousands of classes and all the interactions between them. And we can't always actually look at that in a meaningful way. In this case, we can, because we've honed in on a small subsystem. But the interesting thing in this kind of view is subsets of that big graph. And some of the most interesting subsets are orphan groups and especially tangles. So orphan groups, very briefly, in this case we have some classes and interfaces that are disconnected from the other code in this area. And that's a little bit smelly. That suggests that maybe this code doesn't really belong here. Maybe it does, I don't know. Oh, whoops. Just noticed two of those are actually package info, so that's to do with the Java doc. Should have excluded those. Oh well. More interesting in the context of this particular session is the tangles. We can say here that 23 classes within this subsystem of the code are involved in a tangle. And these 23 classes, if I switch on the group by parent option, I'll see that the 23 classes actually span the package boundaries. So some of them are in analysis, some of them are in class file. If I browse around, I'll eventually see that my descriptor factory is in here. And there is no way I can move classes which are tangled around from one package to another without those packages also being tangled. So if I wanted to break the package level tangle by moving stuff around as opposed to changing code, then I'd be forced, in fact, to co-locate all of these classes in a single package. As I mentioned before, probably in this particular case, some form of dependency inversion would be a better strategy. So with that background in place now, let's go back and have a look at the root area. In fact, let me take out these excludes I put in. So we can say, okay, we have this big tangle at the package level, but I wonder what's happening further down at the class level. So let's go and have a look at that now in the slice perspective. And this is actually, in this particular code base, is kind of a bit scary. We have 1,007 classes altogether in the code base. It's not particularly huge by any means. 431 of those are involved in a class level tangle, and they currently span 33 parents. So the parents of classes will always be packages, leaf packages. And we can get a sense now of how tangled that is by having a look at the extent of the minimum feedback set. So it is at least theoretically possible to have a huge tangle, but where removing a single dependency will fix that tangle. If you can imagine a graph in the form of a circle. I wish I had a nice graphic for this, but I don't at the moment, so I'm just going to say it. And equally, it's possible that you can have an extremely densely connected graph where basically every node depends on every other node. And in that case, the minimum feedback set would be, worst case, is half of all the dependencies in the graph. So this gives us some kind of sense of how entrenched or the extent of the tangledness. And we can see from here, just in terms of where it is on the scroll bar, so about 5% of all the dependencies within this group of 431 classes are part of the minimum feedback set. So those are actually fairly scary numbers. That would take quite a lot of effort to break. And certainly this piece of information now tells us that there is no point trying to move classes around because we will be totally chasing our tails in this case. We do have to, or the strategy will have to be to identify some architectural components or whatever to find the bad dependencies and to start eliminating them. And that will involve a lot of code level activity. So there are three more things I'd like to show you now to finish off this session, and interestingly they all involve tagging. And the first thing I'm going to do now is to say tag all of the items in this group, all of the nodes, and I see these blue balls appearing. So now every class which is participating in this tangle is tagged, and all the other classes in the code base are not. Having done that, I'm now going to switch back to the composition perspective. And note these faded blue balls here, and that means that these items contain something which is tagged. And this allows me now to browse around this the model, armed with this knowledge that all of these classes that are tagged are involved in this big tangle. And this might be useful for me in various scenarios trying to work out what's going on in a particular place. For instance, okay, when I look at any of these classes, I have to bear this piece of background information in mind. Another possibility is to say, well, actually, I'm interested in breaking that tangle of all these classes. And maybe it would be useful for me to work with a subset view containing only these items, but with the hierarchy still in place. So to do that, at the moment, those items are all tagged and the other classes are not. So for this, I would say invert item tags, and now I can say hide tagged. If I go back up to the root here now, I'll see that all I really have left in the code base is this one big class tangle, and I can see how the interplay between the current hierarchy and this. So whenever I'm looking at this view now, I do have to bear in mind it's a subset view. I've hidden a lot of other code, but this can be useful for understanding the nature of the class level tangle. So let me go back to the slice perspective now. Select this outer class layer. It's just to reinforce these are these 431 classes subset view again. I'm going to unhide tagged to get back to the start point. And now I'm going to do something, I'm going to do exactly the opposite of what I did before. I'm going to, well, start by tagging. And now instead of doing an invert, I'm going to hide tagged now. So in this gives me an interesting view in that I'm effectively saying I have one big kind of ugly thing that I don't really want to worry about at the moment. But I wonder if I take that and hide it away and just leave a hinterland view, everything else, that may sometimes help to guide me in terms of kind of divining the underlying architecture within the code base. There are maybe lots of useful things left over which are quite well organized that form a good basis for instance, defining some architecture diagrams as a start point. If we pick the class, the outer class level in this subset view now, the interesting thing is that we have tangles, but they're all very small. The biggest one is 6, and none of them span more than one parent. So they're all nicely organized within a single package. Now, there's something a little bit counterintuitive here. If I switch to the composition perspective, it's interesting that I actually see, although I have no tangles at the class level, I do have tangles at the package level. And this is down really to the packaging introducing tangles that don't exist at lower down. And we see, I'll go back to slice again now, we can see this reflected here in the stats. It's telling me here that at the outer class level in this view now, I only have 2% tangledness. This is the T metric up here. But actually higher up, those numbers go up. The code is more tangled at higher levels. And that suggests, well, what does it suggest? I think in this particular case where half the code base was already tangled, this probably isn't a useful strategy. But I have seen a couple of examples where it's a good approach maybe to hide the ugly stuff and treat that as a hub and use what's left over as the basis for some component thinking. Okay, I have been focusing exclusively on how you use the outer class slice in the slice perspective, but we can in fact apply the same principle with other slices through the code base, so always bypassing the hierarchy, but down to some lower layer. I don't think I'm going to cover that right now. I think we've done enough for this session, so I'll just finish off by saying thank you very much for your attention.